Migraine day progresses, guys. Okay, so wanted to do a little bit of equilibrium by Rice table, because this is a nice combination of how you do stoic, but put things together here a little bit more neatly or organized and start combining concepts. So you got a problem here. Let me see if that light doesn't go on. Never mind. So using the same formula, nitrogen gas plus 3 parts hydrogen gas giving you ammonia. And here's a scenario. You've got 5 moles of nitrogen, 15 moles of hydrogen in a 10-liter tank. Because when you do equilibrium, you have to have molarity. When you reach equilibrium, you have 4 moles of nitrogen left. And I say find K. So I'm going to make a couple notes here. So start 5 mole N2, 15 of H2. It's a 10-liter tank. And at equilibrium, four moles of N2. And here's question mark of K. And it seemed like, oh, is this impossible? No. Take a Rice table and then think about what a balanced chemical equation means, and let's talk our way through this. RICE. If you use a Rice table, and don't have to do it for stoichiometry now, but you can actually do it for what you got here. So let's think. Because you use a Rice table for moles, and you can do it for stoic, but you can also use it for equilibrium here. So you got 5 moles of nitrogen gas, 15 moles of hydrogen, and 0 of ammonia. Those are your initial conditions. And I tell you at the end, you've got 4 moles of nitrogen. Oh, well, you can start figuring this out. Well, that means you lost 1 mole of nitrogen. Well, from a balanced chemical equation, it's 1 to 3. Well, that means you had to lose 3 moles of hydrogen gas. Well, that means you had to make 2 moles of ammonia. Oh, well, this isn't so crazy now. 15 minus 3, you've got 12 moles of hydrogen gas left and 2 moles of ammonia remaining. Okay, well, it's in a 10-liter tank, so you can figure out concentrations pretty quickly. 4 divided by 10 is 0.4. 12 divided by 10 is 1.2. 2 divided by 10 is 0.2. Well, we can get K now. It's not so bad. Your equilibrium constant is always products over reactants. So ammonia squared over nitrogen gas and then hydrogen gas cubed. Well, now we can just start plugging in some values here, and it's not so crazy. So 0.2 squared .4 by itself, and then 1.2 cubed. Oh, well, now it's a calculator problem. It's not even a chemistry problem. And when you do that, you don't have to, I could write the numbers in here, but you don't need to. It winds up being 0.058. It's another small number, meaning the forward process wasn't as favorable as the reverse. You have more reactants at equilibrium than products. Duh, you saw that, and you're good to go. That's not so bad. We're going to do a couple more just like these so you get used to it, because you don't always start off with a 0 here. So we'll do a couple more, but this is not all that crazy. Do a little bit of practice, and that way when you do the problems that I assign you, not so bad. 1 down, 3 to go.